Welcome to a short presentation of our USENIX Security 25 paper, Stack Overflow meets Replication, Security Research Amid Evolving Code Snippets. As you're all aware, Stack Overflow is a popular platform among software developers. It allows them to exchange knowledge among each other in the form of question and answer posts. And the appealing part is that the answer posts can contain reusable functional code snippets that can help accelerate development if developers face this particular problem and then can resort to these code snippets. But this also has made Stack Overflow a very appealing subject of data-driven security studies. For instance, the following works here use Stack Overflow data in some form or another. For instance, to see how these code snippets affect the security of apps or open source projects, or to study how developers interact with each other. So how do these studies generally progress? Well, they usually start with retrieving a snapshot of the Stack Overflow data at this point in time. They might then apply some filtering on this data. For instance, if they're only interested in certain programming languages or only the code snippets contained in the highest ranked or accepted answer post. Based on these selected snippets and posts, they then apply the experimental pipeline. For instance, analyzing the security of code snippets using machine learning or analyzing the surrounding context using natural language processing. And based on these results, they then draw their recommendations and their insights. So generally, these researchers analyze a static Stack Overflow snapshot to which they then apply the filtering and experimental methods to draw conclusions. So let me make one thing clear at this point. The studies that we considered in our meta research here, they all presented valid results at the time they were published, and we are not questioning this. What motivated us to come back to these works and study and replicate them is that Stack Overflow actually is not static. Code snippets evolve over time. For instance, the community on Stack Overflow might make suggestions about bugs contained in posted snippets or even security vulnerabilities. The example here shows one such edit where the code snippet was patched to avoid research leakage. Now, to put this into the bigger picture, Stack Overflow datasets are released on a quarterly model, and developers or interested parties and researchers can access the latest released snapshot from archive.org. So when researchers consult this resource to conduct their studies, they're actually conducting a cross-sectional study because they are only studying the current and latest state of the Stack Overflow data at the point it was just now published. And cross-sectional studies, they can provide valuable insights, and we are not questioning this as mentioned before. But also, we know from other domains that they're not ideal for analyzing evolving phenomena or trends over time. For instance, when studying stock prices or the climate, cross-sectional studies are important, but usually you want to see the bigger picture around the data. So longitudinal studies can reveal trends and recurring patterns across different versions, and this motivated us to look through this lens at how Stack Overflow is being studied. So to break this down in concrete research questions, we were interested in which aspects of Stack Overflow actually could potentially affect prior research. Then, how much do Stack Overflow code snippets and the surrounding context evolve? So can we see that these dependencies for prior work actually are non-static over time? And lastly, how would the results of prior research differ if replicated on a new dataset version? So here we used replication to answer this last research question, if results differ. So we looked through this through case studies. So let's take a look at our methodology. We started with a systematic literature review according to the methodology by Kitchenham et al., to which we identified 42 relevant research works in the literature. We analyzed these works and came up with a set of comparison criteria to see on which kind of data or attributes or features of Stack Overflow they depend. So in the paper you can see this all comprehensively summarized in Table 1. which shows, for instance, that certain works depend on particular programming languages, they make use of certain code scanning tools, they consider code evolution in the methodology or not, or they depend with the results on the surrounding context of these snippets. Now, with this table at hand, we picked 6 of these works, which are highlighted here, which we then later replicated. Before we started this replication, we studied the evolution on Stack Overflow. So we took the Stack Overflow data to analyze how it evolves over time, and then proceeded to concrete case studies for replication. So let me go briefly through some of our results, but I refer you to our paper and also to the extended version of our paper on arXiv for more details on our results. So first of all, we looked at how different programming languages actually trend on Stack Overflow. And we can see that these languages, they trend differently. What you also see marked here with the dashed lines are the times where the works in our systematization actually collected their data. And you can see that depending on when you actually collect the data for certain programming languages, you might see a slightly different picture, because maybe the posts here grow in volume a lot, or they kind of remain steady, depending on the language that you picked. Looking also at the evolution specifically, we looked at the edits that were conducted per month. So how often was a post, or how many posts were edited per month? And we broke this down in different categories. So looking at edits that don't even have a commit message on Stack Overflow, so it's not clear why the post was edited, or if it was auto-edited. Posts that have a message, or edits that have a message, but it was not classified as security relevant using a methodology from prior work. And lastly, also edits that are clearly security relevant according to this methodology from prior work. So we can see that over the last approximately 10 years, there seems to be a kind of steady stream of edits per month, which also means that if you look at a particular snapshot in time here, this might differ from the data you might see a few years earlier or even a few months later. We can also break these edits down a little bit better by looking at the percentage of security relevant edits per month. So if you look at the overall data, including also commits that don't have commit messages, we can see there seems to be a downward trend overall, so that, well, the number of, or the percentage of security relevant edits over time seems to be decreasing. If we exclude these empty commit messages, we see the opposite trend. It seems that over time there seems to be a stationary trend upwards, that more and more security relevant edits are made, and these are also clearly recognizable in the commit messages, indicating that this has security relevance. In particular, in the last years, we saw here an uptick in such security relevant edits. Again, I refer you also to our paper, which breaks this data down a little bit more fine-grained, also, for instance, by programming languages. So to summarize, our meta research question number 2 is that depending on which programming language you pick, they might trend differently. You might see different pictures at different points in time of the data. And we also looked at comments, and we can see that there's a steady upwards trend for increasingly more security relevant comments being raised on Stack Overflow. Now for research question 3, for the replication, I only want to pick 2 of the 6 case studies that we had and give you a brief overview of some of the results that we found. Again, refer to our paper for more details here. So the first case study that I want to briefly include here is a study done by Alfusainey et al. On studying C++ code snippet weaknesses on Stack Overflow. So concretely, they studied whether revisions to C++ snippets increase or decrease the snippet security. They had 3 research questions that we replicated in our work, including what are the types of code weaknesses that are detected in C++ code snippets, how do code with weaknesses evolve through revisions. So this is one of the works that actually considered revisions in the methodology. and what are the characteristics of the users who contributed code with weaknesses. To this end, they built a study pipeline that consumed the Stack Overflow data from 2018 as part of the EsoTorrent 2018 dataset release. They only focus on code snippets of a particular length here, which they then classified using the getLength tool to identify C, C++ snippets, which they then checked for security with the CPP check tool, and the code that was found as vulnerable was indicated as code W. In total, they found about 15,000 vulnerable versions of such snippets within almost 12,000 code snippets across a little bit more than 11,000 posts on Stack Overflow, concretely answer posts. So we replicated their pipeline and fed it to the EsoTorrent 22 dataset to see how results change if the study, for instance, would have been conducted 4 years later. So to compare this, let us put the original results against the replicated results. First of all, we noticed that in the original results, they found that the proportion of vulnerable snippets that improves rose from 30 to 42% as the number of revisions increases. We also found that there's an increase, but it's less significant. We only found that this increases from 3.2 to 7.4%. In terms of what vulnerabilities they found, for instance, that CWE 758 was the 6th most prevalent CWE type in these snippets, with 482 instances. In the newer dataset, this vulnerability increased in prevalence, so we found it to be the 2nd most type, but now with almost 11,000 instances. And indeed, even a new CWE type, 476, is now the 6th most common. And lastly, the authors originally found almost 13,000 instances in the latest versions of 7,500 answers. In our case, we found only 7,700 such instances in the latest versions of almost 6,000 answers. So there's a difference in these results. The second case study is DCOS. Here, Hong et al. Examined how snippet revisions change security-sensitive RP, security-related keywords, and control flows. So they wanted to see if they compared the oldest version and the newest version of a snippet on Stack Overflow, if there is evidence for security fixing inside the code present. With that, they wanted to answer if older posts are more likely to provide insecure code snippets, if accepted answer posts are more secure than non-accepted answer posts, and what types of insecure code snippets were discovered. Again, we replicated their methodology and applied it to a newer data set. So let's compare the original and the replicated results. So the original results reported almost 12,500 insecure posts, the 788 insecure posts with all these 3 features just mentioned. In contrast, we discovered more than 30,000 insecure posts where more than or almost 5,000 of them have all 3 features, and this is a very sharp increase in terms of this kind of posts or snippets. Another result that was kind of surprising is that the original work reported a 91% precision and 89% accuracy, while we on the newer dataset could only achieve an 11% precision and 32% accuracy, while recall remained almost identical. And lastly, the authors did not find any difference between ratios of insecure posts for accepted and non-accepted answers. We found here a higher ratio of insecure posts between accepted and non-accepted answers. And in our case, this difference actually is also statistically significant. So here, the ratios definitely have changed over time. Now, let me wrap up with some recommendations before I conclude. So from our results, we think that it is worthwhile for our community to adopt longitudinal analysis on Stack Overflow data to kind of put a context around these cross-sectional studies. Again, cross-sectional snapshots, they are studying them is valuable, provides definitely valuable insights, but adding longitudinal analysis helps here to distinguish short-lived trends from long-term patterns. And in particular, in the case of Stack Overflow data, the data releases are actually very amenable towards this methodology because of the revisioning that underlies it. You can kind of step back in time by going to older checkouts of these revisions. Secondly, we would like to again raise a call to promote more open science practices, meaning reporting at least the exact software versions that you used in your paper, in your methodology. Ideally even release a Docker image or something similar to containerize your pipelines, your setups, to have consistency here, to allow reproduction and replication. We noticed this in our work that in order to replicate, we had to first reproduce, and reproduction was in many cases not easy because of this lack of open science. In this sense, we also commend, for instance, the USENIX Security 25 and 26 chairs for requiring this artifact availability. To wrap up, cross-sectional studies are valuable, but they are limited in capturing security trends. We think adding longitudinal analysis offers deeper insights, and particularly with Stack Overflow, the dataset allows to do this. Stack Overflow, we think, still remains relevant even in the time of code generators such as Copilot. From anecdotal evidence, when talking to professional software developers and project maintainers, we noticed that while many of the so-called easy questions disappeared from Stack Overflow and Stack Overflow traffic here took a big hit, it is still an interesting platform for more complex or niche coding problems and deeper exchange that, for instance, code generators apparently cannot cover. For future work, we think it makes sense to establish longitudinal research methods from other disciplines to study evolving code data sets, not only when it comes to Stack Overflow. Maybe you're thinking about other data sets that you want to study. Maybe, for instance, aiming at future replication studies for other code bases, such as, for instance, Chromium or GitHub. And with that, I thank you for watching our short presentation video.